Hello everyone, this is Navina Suddapalli and my teammate is Shriya Akula. Today we are going to talk about our project Proof of Presence, which is a prototype similar to POP, which is existing on the Ethereum. And we also did a comparative analysis on different types of attendance verification systems on both Ethereum and Solana. We are going to talk about the comparison in the future slides as well. By the end of this presentation, you would be able to see the prototype of our proof of presence and the comparison of attendance verification systems on Ethereum and Solana. The challenge with the traditional attendance-based system is that they can be easily manipulated. Everything has changed when blockchain technology has been introduced, where decentralization was achieved. One of the most popular decentralized attendance verification system is POAP, which is hosted on Ethereum, and our proof of presence is inspired from it. Our application is mostly on-chain, unlike proof of presence, which is off-chain. Along with prototyping POAP-like system, we also did a comparative analysis, and we will talk about the comparative analysis in the upcoming slides. These are the tools we have used to develop our prototype. Everything is based on the smart contract, and for the solidity, we have initially used Remix VM to deploy and test it. Once it has started working fine, we have deployed it to MetaMask. And for the off-chain metadata storage, we have used Pinata. And for the deployment on testnet, we have used Sefolia. And for the front-end part, we have used React. Once the application was working fine, we have deployed it to Vercel so that everyone can access the app. And in the further slides, you will know how the prototype actually works.
This is Navina again. Now I'll walk you through the demo of proof of presence. This is a single page application. Most of it is based on the smart contract we have deployed. Initially, we have deployed it on Remix VM. Once it has started working fine, we have deployed it to MetaMask through this option. And this is a single page application with organizer dashboard and attendee dashboard. This prototype is to show our understanding of how things work on blockchain technology like Ethereum. And for that, we have to connect to the organizer dashboard to create an event. Let's create an event by connecting to his account. I've selected the owner account to create an event. Let's connect to the wallet. And after that, let's create an event called 333. It's currently 6:04 p.m. Now I'll select 6:05 to start the event, and let's end it at 8. This triggers a transaction request. Let's confirm the transaction. Once the transaction is confirmed, you can view the transaction on the Etherscan. And once the transaction is confirmed, you should be able to create an event successfully. After that, we can attend the event as attendee. Let's go attend the event. You can view this transaction in the Etherscan as well. And let's attend the event we have just created by connecting to the attendee wallet. For that, I'll select the drop down attendee option and connect to his wallet. It has been connected. Now let's attend the event that has been created, event 333, and let's check in. Event has not started yet. It's still 6:04. I'll check in again. It's 6:05. So it's a time bound application. That's why it was not allowed to check in. Let's confirm the transaction. And once the transaction is completed, you will be able to successfully check into the event. The user can only check in during the time period, the specified time period of the event. And we have successfully checked in. And we can mint the unique NFT for the event we have checked in, so that you can show the proof of your presence in the event. Let's fetch the NFT. Here I'm just incrementing the number token ID with every new unique user. And most of this application is on chain. Everything is based on the smart contract. Only off chain thing we have is showing the metadata in Pinata. For that, we are showing the basic details like event ID and the attendee address and the timestamp. This is a Unix timestamp, and you can convert it to the real-time timestamp. And this is how the prototype works. We are creating an event and attending an event. This is fully decentralized, and this project is to show our demonstration understanding of how things work on Ethereum. Thank you.
Everyone, I'm Shreya. Now I'm going to discuss about the comparative analysis. We began by focusing on Ethereum, specifically the POAP system, which is widely used for event attendance. We wrote Node.js scripts using ethers.js and connected to Ethereum via the Alchemy API. Our scripts pulled all transfer events from the official POAP smart contract. We identified mints by checking if the from address was the zero address and collected data like transaction hashes, block numbers, and wallet addresses. We enhanced our dataset by fetching gas usage, timestamps, and calculated mint durations. All the data was saved in .csv and .json formats for analysis and visualizations. Next, our analysis covered 36,868 POAP mints involving 22,899 unique wallets. We observed a clear spike on October 8, 2019, 154 mints in one day, indicating strong real-world event correlation. The average gas used per mint was about 406,000, and this is the average fee per mint. And we calculated the latency between the mints and duration of the participation windows. Graphical representations. The graph on the top left shows a scatter of minted token IDs versus block number. You can see a clear concentration in certain block ranges indicating the event-driven bursts of POA payments, especially in the early stages. The top right charts represents the event count per block. It confirms that POAP minting is clustered. Events cause surges in activity followed by quieter periods. At the bottom, we see the distribution of event types. Roughly 76.4% of the events were mints and 23.6% were transfers. This proves POAP is primarily used for attendance rather than trading. Together, these visualizations show that Ethereum through POAP has a structured and repeatable usage pattern for attendance tracking. Next, we explored whether the similar attendance-based NFT pattern existed on Solana. We queried the Metaplex GraphQL API using a known creator address related to event NFTs. We pulled 1,000 NFT records, but only 113 were potentially related to events, and most NFTs lacked consistent metadata, especially the event date field. And due to the poor metadata quality, we couldn't perform the same statistical analysis as we did for Ethereum. Here are the results. Comparing both chains, we saw that Ethereum's POAP system is highly structured and event focused. Solana's NFT system is more fragmented and creator dependent with no attendance standard. Ethereum offered predictable patterns, consistent metadata, and usable tools. Solana's minting behavior was random, metadata was sparse, and tooling was limited. Even though Solana's is faster and cheaper, that doesn't translate the real utility in this case yet. This bar chart summarizes a qualitative comparison of Ethereum and Solana across key metrics: throughput, transaction fees, security, ecosystem maturity, and finality. As expected, Solana scores higher in throughput and transaction cost. It processes up to 65,000 TPS and average fees are under a cent, which is ideal for high frequency mints. On the other hand, Ethereum scores higher in security and ecosystem. It has over 800,000 validators and a deeply integrated POAP system with APIs, dashboards, and mobile support. Finality is where Solana pulls ahead again with near instant confirmation times versus Ethereum's longer block time in delayed L2 settlement. These trade offs reflect two distinct design goals. Ethereum aims for security and decentralization, while Solana prioritizes speed and scale. Our study found that while Solana has the performance edge, Ethereum's maturity and tooling make it far more suitable for attendance NFTs at this particular stage.
To conclude our analysis, Our system, proof of presence, is mostly on-chain, which is suitable only when small amounts of data is involved. Off-chain solutions like POAP handle large storage, heavy computations, and private data more effectively. And in our comparative analysis, we found out Solana is still fairly new, whereas Ethereum has a very strong community. Depending on your requirements such as efficiency and cost, you can choose either system. If I had to choose one for an attendance-based system, I'd go with Ethereum's POAP, given its mature ecosystem and stronger developer community. Thank you.